So let me start with what I'm going to present. So I'm going to show you the translation initiation pathway, as well as how we can incorporate exotic building blocks and how we couple this incorporation of exotic building blocks with drug discovery. Okay, so we are going to discuss that. I'm just going to discuss one major drug discovery approach that people use. There are several other approaches which I'll let you know about, but I'll not talk about them because it will take a lot of time. So let's start. So okay, let me just do this. Okay, so this is how a typical tRNA looks like. So it's so for the people who have not seen a clover leaf, so this is a clover leaf. Okay, and this tRNA is similar to this clover leaf. So it has 4 different arms, where you have a D arm, T arm, which is we are not really interested in that much because this is just for the stability of the tRNA. We have this anticodon arm where this goes and attaches itself to mRNA, recognizes particular codons, and helps in protein synthesis. And this is the loading arm or acceptor arm where you load different amino acids on this A over here. So this CCA is a common to all of the tRNAs that you have. So basically you have around, so you have 64 codons, different codons, set of codons, right? So you can have different combinations like so you have you have UCTG, right? So you can have 64 different combinations of different codons. So this particular codon is present in all of them, all 64 of them. So the CCA is conserved throughout the tRNA. So this is what tRNA looks like. Okay, so we'll talk about this more, but I just wanted to make everyone clear that even those who are not from bio background, so they should know how tRNA looks like. Okay. So now what happens in the translation process is that you have 3 different steps: initiation, elongation, and termination. We'll talk about them, but before all these 3 steps, you have a prior step where you have to load this amino acid, some particular amino acids, on the respective tRNAs. Okay, so you want to load them on these. So for that you need some enzyme which is called amino acyl synthetase. So it's AARS. Okay, so you use this particular enzyme like METRS. So this is methionine RNA synthetase. So it's similar to so you have each for each amino acid you have different RNA synthetase where they use this particular enzyme to load the amino acid which is related to that particular tRNA on the tRNA. Okay, so you use this METRS to load methionine on this tRNA, that becomes MET tRNA FMET. All right. Now, in eukaryotes, you don't need to go any further. So you can just incorporate this methionine. So eukaryotes generally just incorporate this methionine into the growing peptide chain, or they initiate using the methionine amino acid. But for bacteria or prokaryotes, they formylate this methionine. And why I'm talking about this, you'll get to know in a minute. So this formyl group is very important. So previously scientists didn't know that why can't we manipulate this particular methionine residue in E. coli, right? So most of the expression that is done, it is done in E. coli. You already know that. So why they are not able to change this particular methionine group. This is because it is formylated in the beginning. It is later deformylated. Also, this particular residue, FMET tRNA, like this formyl methionine, is loaded onto the tRNA. And then you have this sequence that recognizes the starting codon, right? So this particular assembly is also important for initiation of the translation process. Okay, so we'll talk more about this and how the initiation takes place. So this is a brief schematic of how the initiation takes place. Okay, so you have 30S ribosomal subunit, right? And then you have 50S ribosomal subunit in bacteria. In eukaryotes, you have analogous subunits of 40S and 60S RNA ribosomes, right? So this first 30S subunit binds with all the different initiation factors like AF1. So these are like initiation factor 1, initiation factor 2, and so on. So they bind with the 30S subunit, and this whole subunit goes and binds to Shine-Dalgona sequence, which is a which is a very UG rich sequence in your mRNA, and then this particular 30S subunit has the anticodon sequence on the subunit, and it goes and binds to the mRNA. And then after that, the tRNA, FMET tRNA that we talked about in previous slide comes and binds to this particular assembly. And now, after binding of this FMET tRNA, 50S subunit comes and binds, and all the initiation factors goes away. So this is called the initiator complex. So this is where the protein synthesis begins. Okay, so this is a very important aspect of ribosomal protein synthesis. So after the formation of this particular assembly, you have 3 sites in your initiator complex. That's E site, P site, and A site. Your particular tRNAs that we discussed about, like there are several tRNAs, come and particularly bind to this particular codon at A site. And then after binding, the codon recognition takes place, and the peptide, the amino acid on the P site is transferred on the A site. Okay, and the peptide bond is formed. Now, after this step, the P site, so this whole initiator assembly moves forward, and the codon, which is at A site, comes to P site now, and then from the E site, the tRNA that has been relieved from its amino acid is kicked out of the system. So now you have amino acid, a peptide which has 2 amino acids, and then you go on repeating this process of recognizing the codons, and you get the whole peptide or the protein. If you guys have any questions in the between, like in the middle, just stop me and ask. Okay, so that's fine.
Hello.
Yeah.
You mentioned about this amino acyl synthetase modification.
Yes.
So, is it some kind of epigenetic modification, or like, what is it doing there? Like, why is it needed?
Are you talking about this formylation of this methionine?
Yeah.
I think this particular formylation is more of a conserved sequence. Like it helps recognize that you are installing a methionine over there. So there is this particular enzyme that's called methionine transformylase. So it helps you recognize that you are starting your initiation with FMET, like with methionine. So I think it's just for the recognition purpose. I don't know any epigenetic involvement of this particular tRNA or like FMET, like formylation to anything. So if you know about it, just let me know also. I don't know much about the epigenetic aspect of this particular like assembly, right? So yeah. I mean, it's there for the recognition that it's getting started from there. That's all.
Okay.
Mm-hmm. Okay.